final question we're going to look at is one involving a cylinder. So here we've got a cylindrical silo that's required to hold 8,600 cubic meters of wheat. Okay, where we've got two parts to this question. First, we're told to find an equation for the surface area of the silo in terms of the radius, and then we're asked to find the minimum surface area required to hold this amount of wheat to the nearest square meter. So before we go on, it's worth just reviewing what we know about cylinders. We know for a cylinder, the two defining characteristics are the radius and the height. So we've got a radius of something and we've got a height of something. The surface area, we have two circles, so it's 2 pi r squared, plus that kind of curved surface around the middle, and the area of the curved surface is 2 pi rh. I'm not going to prove that now, but that's a relatively straightforward thing to show. If you imagine unfolding the cylinder and you work out this middle part gives you a rectangle, you can work out that its height is h and its width is 2 pi r, the circumference of the circle. The area of a cylinder, it's not the area, the volume I should say, of a cylinder is the area of the face times the height. So the area of this circle is pi r squared and the height is h. So those are the two formulae that I have about cylinders, and I'm going to use those to help me out. And now what we're told is what the volume has to be, and then it asks questions about minimizing the surface area. So we're going to find a surface area function, and that's the thing we're going to be minimizing, and we're going to use information about the volume to help us out with that. Okay, so we know that the area, I'm just going to use A rather than SA, A of X, or A of R, sorry, because we need it in terms of the radius. Okay, it's going to be this thing. That's my surface area formula, but again, it's got an h in it at the moment, and I've got to get rid of it, and I'm going to use my volume formula for that. I know that the volume has to be 8,600. Okay, so in fact, this part here is what I'm going to use to knock out the h in that equation. So let's do that. I know that pi r squared h is 8,600. I'm going to rearrange this to make h the subject. It is good practice when you're dealing with things like pi to leave those in the equation for as long as possible, because you do get some nice things come out. So now that I've got this expression for h, I can replace it in the equation. So I get 2 pi r squared plus 2 pi r times 8,600 divided by pi r squared, and you can see here why we don't put numbers in too early. Those pi's are going to cancel, which is nice, leave me something rational. One of the r's is going to cancel, and I'm going to be left with 2 pi r squared plus 2 lots of 8,600. That's really testing me. That's going to be 1,7,200. Yep. Divided by r. So that is going to be my surface area function in terms of r. So that is part A of this question. Next thing, find the minimum surface area required to hold this amount of wheat to the nearest square meter. So I need to minimize this function. To minimize the function, to do this, we are going to need to differentiate and then solve with the derivative equal to 0. I'm going to rewrite this as r to the minus 1 to make it a little bit nicer to differentiate. So I'm finding out a dashed. This is 4 pi r. Bring the power down. Reduce it by 1. So this is my function for the surface area, and we want to minimize this value. Not minimize, we want to set this thing equal to 0. So stationary points occur when the derivative equals 0. Yep. Now let's tidy up here. I'm going to multiply everything by r squared, so I'm going to get 4 pi r cubed minus 17,200 equals 0. I'm going to add this to the other side, so I'm going to get r cubed on 4 pi. No, what am I doing? 4 pi r cubed equals 17,200. R cubed equals 17,200 on 4 pi. So whatever the radius is that's optimal here, it's going to be the cube root of this number, 17200 divided by 4 pi. The question asks us to the nearest square meter, so we're going to round this to the nearest whole number. I'm going to bring my calculator in. So we have to do 17200 divided by 4 divided by, oh dear, we don't have a scientific calculator here, divided by pi, and then I need to find the cube root. And I get this number is equal to 11 square meters. Sorry, 11 meters, sorry, is the radius. The question specifically though asks us what the minimum surface area is. So this is the minimum, the radius that will give us the minimum surface area. We now need to determine what that surface area is. So we need to work out A of 11. What's the surface area of a cylinder, this silo, if the radius is 11? Our function was this guy here. I'm just going to copy that actually because I can't remember that. Okay, there we go. Let's substitute that in. That was an R. I don't know what happened there. Okay, so again, this is just a matter of churning this out of on my calculator. But we have done all the hard work. Your calculator is a bit more advanced than this one is, so you might find this a bit easier. I'm going to do it in 2 parts. So 760 point, I'm going to take a couple of decimals, 27, just to make sure I eliminate any potential rounding error. 17200 divided by 11 gives me 1,563.636363. So 64, that'll round to. Add these two guys together. And my final result is going to be 2,324 square meters is the total surface area of this particular silo.